In 1984, two field workers discovered a body in a bog outside Cheshire, England. Officials named the body the Lindo Man and determined that he had suffered serious injuries including blunt trauma and strangulation. But the most shocking thing about this gruesome story was that they were able to determine these details from a body that was 2,000 years old. Typically, decomposition would make such injuries harder to detect in a body buried just weeks earlier. So, why was this corpse so perfectly preserved? And why don't all bodies stay in this condition? The answers to these questions lie just 6 feet below the ground. It may not appear so lively down here, but a single teaspoon of soil contains more organisms than there are human beings on the planet. From bacteria and algae to fungi and protozoa, soils are home to 1/4 of the Earth's biodiversity. And perhaps the soil's most important inhabitants are microbes. Organisms no larger than several hundred nanometers that decompose all the planet's dead and dying organic materials. Imagine that we drop an apple in the forest. As soon as it comes in contact with the soil, worms and other invertebrates begin breaking it down into smaller parts, absorbing the nutrients from what they consume and excreting the rest. This first stage of decomposition sets the scene for microbes. The specific microbes present depend upon the environment. For example, in grasslands and farm fields, there tend to be more bacteria which excel in breaking down grass and leaves. But in these temperate forests, there are more fungi, capable of breaking down more complex and woody materials. Looking to harvest more food from the apple's remains, these microbes release enzymes that trigger the chemical reaction called oxidation. This breaks down molecules of organic matter, releases energy, carbon, and other nutrients in the process called mineralization. Then, microbes consume the carbon and some nutrients and leave behind several other nutrients as excretions. As insects and worms eat more of the apple, they consume more surface area for these microbial enzymes to oxidize and mineralize. Even the excretions they leave behind are mined by microbes. This continues until the apple is reduced to nothing. This is a process that would take 1 to 2 months in a temperate forest. Environments that are hot and wet support more microbes than places that are cold and dry, allowing them to decompose more quickly. But there are a few environments too hostile for these multi-talented microbes, including the peat bogs outside Cheshire, England. Peat bogs are mostly made up of highly acidic sphagnum mosses. These acidify the soil while also releasing a compound that binds to nitrogen, depriving the areas of nutrients. With nothing to break them down, the dead mosses pile up, preventing oxygen from entering the bog, and the result is a naturally sealed system. Whatever organic matter enters a peat bog just sits there, like the Lindo Man. The acid of the bog was strong enough to dissolve relatively simple material like bones and turn more complex tissues like skin and organs pitch black. But his corpse otherwise was so well preserved that we can determine he was healthy, mid-20s, and potentially wealthy as his body shows a few signs of hard labor. We even know the Lindo Man's last meal, a still undigested piece of charred bread. Scholars are less certain about the circumstances of his death, while a cold-blooded murderer is a possibility and the extremity of his injury suggests a ritual sacrifice. Even 2,000 years ago, there's evidence that the bog was known for its almost supernatural qualities, a place where the soil beneath your feet wasn't quite dead or alive. Subscribe to eWorld to know more about such rather supernatural stories from around the world.